Yesterday we went through and we talked about solving for mass. It's just a different variable. We went through two problems on the half sheet with mass. Then we talked about the difference between elastic and partially inelastic collisions. They both start apart, they both end apart. Depending upon the situation, they may or may not have deformation. So we went through one yesterday, and what we have to do in order to determine if kinetic energy is conserved is we go through and we say, well, the sum of all my kinetic energy at location 1 is equal to question mark. We do the same thing at location 2, and then we compare these two. And if KE1 equals KE2, then KE is conserved, which then means then it's an elastic collision. Okay? Then it's an elastic collision. If the answer to that is no, they aren't equal, then it's a partially inelastic. So what I put on the board is question number 1 from the solving for mass side yesterday. And yesterday we went through and we solved this problem for what is the mass of the car, and the mass of the car ended up being 1,500 kilograms. So these were our unknowns originally. So what I did, just to show you another example, is I went through and I calculated the kinetic energies for the before, some of your KE1s, and I solved for the sum of your KE2s. And these are the two different numbers I have. So when we find the sum of our kinetic energy at location 1, I take object A at location 1 and object B at location 1, and I find the kinetic energy, which is 1/2 mv squared. I do the same thing at location 2, object A at location 2 plus object B at location 2, 1/2 mv squared, and we get these numbers. So like 1,100,000 some joules versus 300 some joules. So was kinetic energy conserved? No, they're different. What happened while it's a collision? We absorb some energy is absorbed during the crumpling of these cars. There's noise, there's lots of other things. But because the kinetic energy is not conserved here, because these two do not equal one another, then this particular is a partially inelastic. Okay, so that's just kind of to show you an example of what if they don't equal one another. So the sheet that you picked up on the way in is the final worksheet of the unit in terms of homework. There's a lab we're going to start on Monday, and that lab is going to take us some time. So this is kind of like, again, it's doing conservation of momentum problem, then doing KE1, sum of KE2, is it conserved, yes or no, what kind of collision is it then? They start apart, they end apart, and that's what this homework sheet is. And I don't have it built in Canvas yet. It should just take me a few minutes and I'll have it up and running and posted in Canvas. So today is what you're going to do. That's what you're going to wrap up. Also, the sheet called collision problems, I believe it's called collision problems, is due on Sunday in Canvas. So wrap that up and then get started on this sheet today. When you have questions, please let me know. The lab we're going to do on Monday and Tuesday is going to take us some time to get the data collected, and then there's some calculations that will take us some time to go through as well. So let me know what questions you have, and I'll answer them for you.